87 is a pretty important problem because we're going to do a problem of the week really similar to this. We're going to talk about it from time to time, and it's going to become one of the main ideas of calculus. So we really want to make sure we get this, and I want to make sure you understand the things I'm going to do with it on this discussion. This wasn't necessarily in the book, although it would have been nice if it had some problems like this. But again, you're going to do a problem of the week on this really soon, so let's get a jump on that. Just a quick recap about the way sigma notation works. You start with the number on the bottom and plug it in for the variable. Now I used x instead of I. The book did have I here. I used x because I'm going to graph this in just a second, and it just looks more like something we would graph. But x equals 1 first, so I plug that in for x and see what I get. And then I plug in the next number up, which is 2, and see what I get. And I'm going to keep doing that until I plug in 5 here. I'll put a little dot, dot, dot in between because I'm skipping stuff. And I'm hopefully going to be able to pick up on the pattern and not have to do plugging in 3 and 4, but you can if you need to. So 2 times 1 is 2 plus 1 more is 3. 2 times 2 plus 1 more is 5. So it's going to be the odd numbers. That's what's happening. And then 2 times 5 is 10 plus 1 more is 11. And I'm stopping once I get to that top number being plugged in for x. So the easiest mistake to make here is just assume that we start at 1 and we have 5 terms. That is how this one worked out. There are definitely 5 terms. That only is the case when you start with 1 on the bottom. So if you start with something else, you've got to be really careful of where you end up. So that's not really pertaining to this problem, so I won't get into it too much more. I'm going to go ahead and add stuff up. Now, another trick that you can look for when you're adding things up like this is oftentimes there are pairs of numbers that add up to a multiple of 10. Like 9 and 11 add up to 20. 7 and 3 add up to 10. So that's 20 plus 10, 30 plus 5, 35. Just a quick way to add things up in your head, save you some work later on. So the total of that is 35. All right, that's an important idea. Let's keep that in mind. Now I'm going to graph this thing. I'm graphing the line, 2x plus 1. This will be the shading I'm going to do. So between that line and the positive x-axis, we'll do a little bit of shading in here. And stop at 5, so there we go, shaded area. So let's suppose I want to figure out the area that's shaded in right here. All right, well I'm going to do a little bit of quick geometry, easy geometry. I'm going to erase that shading for a moment. I've got a rectangle right here, and I've got a triangle there. So I'm going to find the area of the rectangle and the area of the triangle, add them together. That's the total area that I had shaded in a second ago. Well, this is up to 1 and over to 5, so 1 times 5 is 5. It should be pretty straightforward. The triangle is going to be 1/2 your base, which is 5, times your height, which went from 1 to 11, so that's 10. So that's going to be 25. So the area underneath this trapezoid, I guess if you want to call it full shape here, this whole thing is 30. And here's where the calculus starts to come in. And then we're going to tie it back into the sigma notation here in just a minute. If I throw in the word Riemann in here, I'm getting ahead of myself into calculus. Sometimes it just comes out. But I should be talking about sigma notation with you all because that's what we're talking about here. So what I want to do is try making a bar graph where I'm going to kind of approximate the area that was underneath this shape, between the x-axis and this shape, by making some bars. So there we go. Now I've got a bunch of bars where the right, we would call this right endpoint bars, because the point that corresponds on the graph is at the top right of the bar. And what we're going to do is approximate the area here using these bars. Now you probably can look at this right away and say, wait a minute, this is going to be an overestimate because we've got all these little extra parts here. And that's accurate, it will be. It's going to be an overestimate. So this is our first attempt at finding the area this way, and then we're going to mess around and try some other stuff. So let's just find the area of these bars really easy. Each one's 1 unit wide. We can just use their height to figure out their area. So that's 1 by 3, that's 3. 1 by 5, 1 by 7, 1 by 9, 1 by 11. And those terms probably look pretty familiar. We're going to come back in a second and talk about why they should look so familiar, but they're going to add up to 35. Okay? Now, we figured out the area through geometry, it was 30, but we got 35 this way. So, somewhat close. We kind of knew going in it was going to be an overestimate. So, we'll take it. All right, now let's do some left-hand bars. To do that, I want the bars to begin where their left corners touching the points on this. And doing it this way, I had to kind of cheat a little bit because I don't want to go past 5 if I'm trying to find the area underneath this thing. So I had to kind of stick one over here at with the top left part of 1. But let's just run with that for a moment. Don't get too caught up on why I'm doing all this stuff quite yet. That's the idea, and this is going to be an underestimate. We can probably kind of assume that. So look at an area, 1 by 1, 3 by 1, 5 by 1. Add all these up, that's going to be 10, 20, 25. So the area is going to be 25 if I do it that way. So we've got an overestimate and an underestimate. And if you think about the average of the two, it's right on what it's supposed to be, which was 30. So let me show you one more way you can do the bar graph. And that's by using midpoints. This is probably going to be the best way to go about this. So instead of using the left or the right-hand point, I'm going to go halfway in between and use that to make my bars. So there we go. I got my 5 bars with the height being the midpoint of each segment here. So now I've made my bars where I've got 5 of them again. It's the area underneath the curve. I did get off a little bit. It looks like it sticks over further than it should, and some of these overlap. But if they were perfectly the same size, it should be 1 unit each. But again, the height is the midpoint between each of these points in the graph. Right, that was what I was going for anyway. It got kind of off over here. But these two look pretty close to what I wanted to look like. So in this case, 1 unit wide. This one's 2 units tall, 4 units tall, 6, 8, and then 10. So those are the areas. So add these up, 10, 20, and 30. And that was exactly where I wanted it to be. So if you use a midpoint, you can get a pretty good idea of what the area is going to be. Okay. So some things you're going to explore, and this is going to be the problem of the week that's coming. Think about ways we could get a more accurate representation. All right, well, the more bars we have, the better it's probably going to get. To get more bars, I really need to take thinner slices so I can fit more in there. And there's less wasted space if I do that. So you're going to play around with some of those ideas. Now I want to go back to the original problem. I got 35 doing it that way. If you kind of look at where we're going, we're plugging in 1 first, then 2, then 3, see what we get. What I actually did here was a right-hand Riemann sum, basically. And that's why you got the same total as you did with this graph. So that's kind of the same idea as estimating the area under that curve by making bars at the top, or where the top right of the bar is at each of those points. And that's actually what that formula is doing. Now we can get more specific, and of course you will as you get to calculus. And it's going to become one of your main ideas in calculus, but this is what leads up to it. So it's a really important concept, making sure that you can do the math part here. But again, we're going to do some exploration with finding the area underneath of a line, and eventually some more complicated things. So you kind of get your feet wet with the calculus part.